All right, today we are diving into the absolutely incredible story of a telescope that completely changed how we see the universe. Seriously, this isn't just about a bigger lens, it's about a whole new way of looking. This is the story of magic.
Now you might be thinking, what does a French novelist have to do with astrophysics? Well, Proust totally nailed the spirit of this story. We're not launching rockets into deep space here. Instead, we're going to see how some of the most brilliant minds on Earth figured out how to see the cosmos with entirely new eyes. And they did it right from our own backyard. So let's get into it.
You know, when we look up at the night sky, it seems so peaceful. But the truth is, our universe is an incredibly violent place. We're talking about exploding stars, supermassive black holes just gobbling up entire star systems, and things spinning faster than you can even imagine. The biggest problem? Almost all of this action is completely invisible to our normal telescopes.
Yeah, all these cosmic powerhouses, like the black holes at the center of galaxies we call active galactic nuclei, or the most powerful explosions in the universe, gamma-ray bursts, they belong to what scientists call the non-thermal universe. All that really means is they're not just giving off heat and visible light. Instead, they blast their secrets across the cosmos in the form of super high-energy particles of light called gamma rays. Think of them like cosmic messengers, carrying clues about the most extreme physics imaginable.
Okay, so it sounds pretty simple, right? If the secrets are in the gamma rays, just build a gamma ray detector and point it at the sky. But there's a huge catch, a massive shield that protects us every single day, but in this case, it's also blinding us. And that shield? It's our own atmosphere. It's so thick that it stops these high-energy gamma rays in their tracks, way before they could ever reach a telescope on the ground. For decades, this pretty much seemed like a deal-breaker for ground-based gamma-ray astronomy. But then, somebody had a brilliant, game-changing idea.
And here is that big idea, the total paradigm shift. What if the atmosphere wasn't the problem? What if it was actually the key to the solution? Scientists realized that when a gamma ray from deep space smacks into our upper atmosphere, it shatters, creating this cascade of secondary particles, what's known as a particle shower. And that shower, it produces its own unique, ghostly signal.
That signal has a name, Cherenkov radiation. Now I know what you're thinking. Hold on, nothing can go faster than the speed of light. And you're right, in a vacuum. But light actually slows down when it passes through stuff, like air. The particles in that shower, though, they can actually travel faster than the local speed of light in the air. And when they do that, they create this faint blue glow.
The absolute best way to wrap your head around this is to think of a sonic boom, but for light. Right? A fighter jet breaks the sound barrier, it creates a shock wave of pressure we hear as a boom. Well, one of these particles breaking the light barrier in air creates a shock wave of light. It's literally a light boom. How cool is that?
So as this whole particle shower cascades down through the sky, it's shooting out Cherenkov light in a cone shape. By the time that cone of light reaches the ground, it's spread out into this huge but incredibly faint pool of light, hundreds of meters across. That is the signal they needed to find. The challenge, of course, was actually catching it. And believe me, catching it is a monumental challenge. This flash of blue light is unbelievably faint. We're talking about maybe 1 photon per square meter for the weak signals, and it only lasts for a few nanoseconds, a few billionths of a second. To see something like that, you need a very special kind of eye.
And that special eye is the MAGIC telescope. Perched high on a mountain in the Canary Islands, this entire instrument was built from the ground up for one single purpose: to capture those fleeting, ghostly flashes of Cherenkov light. To even have a chance, it needed to be enormous. The mirror on the first MAGIC telescope is 17 meters across. That's about 56 feet. To put that in perspective, that's like a 5-story building turned on its side. It was a giant light bucket designed to collect every single photon it possibly could, but even that wasn't quite enough.
See, the whole point of MAGIC was to push the limits, to see lower energy gamma rays than anyone had before, to peek at fainter, more distant events. They had to squeeze every single drop of performance out of this amazing machine. But how?
So put yourself in their shoes. You've built this massive, state-of-the-art telescope. How do you get a nearly 20% boost in performance without breaking the bank? The obvious answer is, well, just build an even bigger, way more expensive mirror. But the real answer? Well, it's a story of pure scientific genius.
And this is where it gets amazing. Instead of spending a couple €100,000 on more mirror, a PhD student named David Panic had a totally different idea. He suggested they coat the telescope's light detectors with a special milky lacquer. The total cost for the materials? Less than €100. I mean, come on!
The physics here is it's beautiful. That milky coating acts like a diffuser. When a photon of light hits it, it doesn't just pass straight through. It gets bounced around inside the coating. This gives it a much longer path and more chances to actually get picked up by the sensor. And the net effect of this simple trick is staggering 19% increase in the telescope's efficiency, all for the price of a nice dinner.
So you've got this giant mirror, this ingenious, super cheap upgrade. The telescope was finally ready. It was time to point this new cosmic eye at the sky and see if all the theory and all the engineering would actually pay off. It was time for first light.
For their first target, back in February of 2004, they chose the Crab Nebula. It's what's left of a star that went supernova 1,000 years ago, and it's one of the brightest and most reliable sources of high-energy gamma rays in the sky. It's basically the universe's ultimate test pattern, the perfect thing to calibrate a brand new telescope on.
And the result? An absolutely, undeniably rock-solid detection. They got a signal with a statistical significance of 13 sigma. Now, in particle physics, 5 sigma is the gold standard for calling something a discovery. 13 sigma is like looking out at an empty desert and seeing a skyscraper instantly appear. It was a massive success.
Okay, so test number 1 passed with flying colors. Feeling pretty good, they turned the telescope to another target during that same first run, an active galaxy called Markarian 421, which is powered by a supermassive black hole.
And here, the signal they got back was even more spectacular. 30 sigma. This was a total shock. Usually, Markarian 421 is way fainter than the Crab Nebula. This incredibly powerful signal meant one thing. The galaxy was in a rare, active flaring state, and magic just happened to catch it right in the act.
And just like that, with those 2 huge detections, the team had done it. They'd figured out how to use the atmosphere, they'd built a revolutionary machine, and they'd proven its power with an unbelievably clever low-cost hack. A brand new window on the most violent events in the universe was now officially wide open.
And that really leaves us with a final thought, doesn't it? This whole story is about learning to see with new eyes, about turning a barrier into a tool. By literally transforming our own atmosphere into a giant particle detector, we've opened up a whole new frontier in astronomy. It just makes you wonder, what other invisible, cosmic secrets are out there, just waiting for us to finally see them?